this session of complex number, we'll discuss the imagination of imaginary unit, and this work was done by Jean Robert Argand. Argand was not the regular mathematician. He was managing a bookstore in Paris and he published the idea of geometrical interpretation of complex number. This geometrical interpretation of complex number known as Argand diagram, right? To imagine the concept of imaginary number, we have to go through some basic concepts, and I am going to discuss 1 into minus 1 equals to minus 1 on real number line. This one is the real number line. If we multiply 1 by minus 1, then on the number line we can move from 1 to minus 1, right? That means if we multiply 1 with minus 1, there is a rotation of 180 degree. It indicates that if you multiply any number with minus 1, then there is definitely a rotation of 180 degree. If you will multiply 3 with minus 1, then you move from this to this one. That means once again there is a rotation of 180 degree. If you multiply minus 5 with minus 1, then you can get 5, and on the number line it will be represented from minus 5 to plus 5. That means there is once again the rotation of 180 degree. And hence by multiplying any number by minus 1 on real number line, there is a half rotation, and that means this rotation is by pi, right? Now I am going to multiply minus 1 with minus 1, and as we know that minus 1 into minus 1 will be equal to 1, and it will be represented on the number line according to this. First of all, we are going to multiply 1 with minus 1. If we multiply 1 with minus 1, there is a rotation of 180 degree. That means we move from this point to this point. Now multiply minus 1 with minus 1, then there is the half rotation. That means you will move to this point, and hence there is half rotation if you multiply 1 with minus 1, and if you multiply minus 1 with minus 1, then there is once again the half rotation. That means you will move to the same point. Now I am going to discuss another concept, and we are going to find the square root of a number. What is square root? A number will be multiplied the number itself, then you will get the other number. That means multiplying 2 by 2 you will get 4, and hence the square root of 4 will be 2. There is another square root of 4. If you multiply minus 2 into minus 2, then you will get 4. 4 will have two square roots. One is minus 2 and another one is plus 2. 3 into 3, then you will get 9, and minus 3 into minus 3, you will get 9, right? That means 9 will have two square root. One is 3, another one is minus 3. The positive value of square root is known as principal value of the square root. Now I am going to represent the square root of these numbers on a number line. On the number line, if you multiply 2 by 2, then you will get 4. Multiply minus 2 by minus 2, then you will get 4, right? From this discussion we can say that the square root of the positive number will exist on this number line, right? Now I am going to discuss the square root of a negative number. Now we are going to find the square root of minus 4. To get minus 4, we have to multiply a number with the number itself such that we can get the value of minus 4. But we know that if you multiply any positive number a into a, then you will get the new number, and that number will be positive. In the similar way, if you multiply any negative number with the number itself, then once again you will get the basically positive number. That means there is no number which will be multiplied by the number itself to get minus 4, and hence on the number line the square root of minus 4 does not exist. By multiplying any number with the number itself on this number line, you can't get minus 4. That means the square root of minus 4 does not exist on this number line. It indicates that this real number line is not complete. On this number line we can find the square root of the positive number, but we can't find the square root of the negative number. Hence we have to introduce a new number system which includes each and every number such that we can find the square root of positive number as well as square root of negative number. Now I am going to discuss the introduction of new number system such that we can find the square root of positive number as well as we can find the square root of the negative number. Now consider the square root of minus 4. Square root of minus 4 can be written as root over minus 1 into 4, and it will be further written as root over minus 1 into root over 4. As we know that the root over 4 will come out 2, hence the main problem is this one. We have to find the square root of minus 1. Now first of all, take this number line system. We have discussed that if the number 1 will be multiplied by minus 1, then there is a rotation of 180 degree. If the number 1 will be multiplied by root over minus 1, then it is possible that we'll move to the point at this. That means if we multiply the number 1 with root over minus 1, it is possible that there will be the rotation of 90 degree. Further, this number will be multiplied by root over minus 1, there will be the rotation of 90 degree. If now multiply this number with root over minus 1, then it will be the rotation of 1/4. That means you will move to this point. Once again multiply this number with root over minus 1, then you will reach at this point, right? That means if the number 1 is multiplied by root over minus 1, then there will be the rotation of 90 degree. If this complete number is multiplied by root over minus 1, then once again the rotation of 90 degree. Once again it will multiplied by root over minus 1, then there is a rotation of 90 degree. Once again it will multiplied by root over minus 1, then the rotation of 90 degree. That means if the number 1 is multiplied 4 times by root minus 1 and reach the same point. Now think that if the number 1 is multiplied with root over minus 1, we are not reaching on the real number line. It indicates that definitely there is another number line which must be perpendicular to this real number line, and this number line can be termed as imaginary number line. A new number system includes two axes. One is horizontal axis, this one is the horizontal axis which includes the real numbers, and one is the vertical axis which includes the value of imaginary number. Now I am going to draw a vertical line which is perpendicular to this horizontal line. This horizontal line contains the real numbers and this vertical line will contain the imaginary number, and this point will be root over minus 1 and this will be equal to I. That means this is the way to introduce the imaginary number. Now we are able to imagine the concept of imaginary number, and the whole new number system is introduced, and this whole new number is known as complex number, and the complex number will be represented on a plane which consists of two axes. One is the horizontal axis. This horizontal axis will contain real numbers, and this one is the vertical axis which contains the imaginary number, and the complete plane is called the complex plane. And hence we are going to define a complex number. The complex number will be represented by a plus bi. This a is called the real part of this complex number, and this b is called the imaginary part, and I will be the imaginary number which will be equal to root over minus 1. Now we are going to represent any complex number. There is a complex number which will be 2 is the real part of this complex number, this 2 is the imaginary part of the complex number. Now we are going to represent this complex number on the complex plane. We have to go for the right by 2 unit for the real number 2, and we have to go upward by 2 unit to represent the imaginary part. This is the point which will represent 2 plus 2i. Now we have to represent this complex number on the complex plane. Minus 2 is the real part of the complex number and 3 is the imaginary part of this complex number. We have to move 2 unit towards left to get minus 2. That means this one is the real part, and then we have to move 3 unit upward to get the value of imaginary part, and hence this is the point which will represent the complex number minus 2 plus 3i. We have to represent this complex number. Minus 1 is the real part of this complex number, minus 3 is the imaginary part of this complex number. That means we have to move 1 unit towards left to get the value of real part of the complex number, and we have to move 3 unit vertical downward to get the imaginary part minus 3, and hence this is the point which will represent this complex number. This complex number has the real part equals to 2 and the imaginary part equals to minus 2. Now, to get the real part, we have to move 2 units from the origin towards right, and then we have to move 2 units vertical downward to get minus 2 of the imaginary part, right? And hence this is the point which will represent the complex number 2 minus 2i, right? Now suppose we have to represent the complex number 2i. This complex number has only imaginary part, and this imaginary part equals to 2, and the real part of this complex number is 0, and hence this is the point which will represent the complex number 2i. Let's say we have to represent the number only minus 3. To represent this number minus 3 on this complex plane, this number has the real part equals to minus 3 and there is no imaginary part of this number, and hence this is the point which will represent this number minus 3. This one is the origin. This origin can be written as 0 plus I0. Origin will have the real part equals to 0 and imaginary part equals to 0. That means any number will be the basically complex number, and the real number is the subset of the complex number. Hence the superset of the number system is the complex number,